Okay, so as I mentioned, we're starting geometry today. Now, one of the things about geometry is going to be very different than algebra. It's going to involve a lot more discussion because, as I mentioned earlier, actually I mentioned a long time ago, you're going to be writing all our definitions. And so we're going to practice that a little bit today. The other thing is, as we're moving through these lessons, there is no way that you can write down everything that I put on the slideshow. You won't be able to keep up, and I'm not going to wait for you. So you have to figure out what's important and what's not. What do you need to include and what do you not need to include? Okay, so today, for instance, if you see, the second slide has two pictures, and the reason I gave you these slideshows ahead of time is because I want you to be able to get into the discussion and not sit there and draw a picture of a dog. Okay? Any problems so far? Beautiful. Let's see. Andy, since we started with you, I'll stay with you. Could you tell us some similarities about those two things, please?
They're both pets.
Okay. Keep going.
They're both orange.
Okay.
They both have fur.
Good.
They both have tails.
They both what?
Have tails.
Okay, good. Yeah, well, you can see it in the back of the thing on the right over there. What else?
They both have ears.
Good. And we can go through all the body parts, right? They both have a tongue, they both have two eyes, they both have a nose, a tail, four legs, et cetera, et cetera, et cetera. So we'll just say same body parts. Good. Anything else? No? Anybody else? Similarities? Aiden, differences?
Well, one's a cat, one's a dog.
Okay.
The one on the right, like the fur, it's like kind of like stripy. The one on the left has like a snout, or like a flat face.
Mm-hmm.
The one on the right, its ears are like up.
Mm-hmm. Perfect. Yeah, good. Now we're getting in depth. There we go. Come on.
The one on the left, its mouth is open.
Good.
The one on the left is fur. It's like more like shaggy kind of.
Okay, longer fur?
Yeah.
Uh-huh. Anybody else? Other differences? So we did that. We did that. How about this? Aaron?
They both have like 4 legs.
Oh, good. They both. So we're doing similarities first. Okay, similarities. They both have 4 legs. Excellent. What else? That's it. That's the only thing they have in common.
That's the only thing I.
Interesting. Eva.
They're both brown.
They're both brown. Good. What else? Go. Read.
Both have backs.
Very nice. They both have backs. Excellent. What else? No other similarities? How about their differences? Aaron, back to you.
One is like an object, and one is like
Okay. One is alive and one is not.
yeah.
However, one was alive, no longer. Right, we're assuming that's a wooden chair, I think. We got that.
Chair, a bridge between the legs.
You mean those things, right? Where's my laser pointer? doesn't show up on the screen. It shows up over here. Get it, get it, man. Sorry. It doesn't show up when I put it in the screen. Interesting. So it's got a something connecting the legs. The dog doesn't have anything connecting its legs. What else? Go.
The dog doesn't have ears or dirt.
Good. What else? Good. Okay. So what I would like you to do is write a definition of that. Okay, so in simplistic terms, what is that? It is not a dog. It is not an animal. Perfect. It's a picture of a dog. Okay, now that seems nitpicky. It will become relevant later on. Okay. However, don't change your definitions because I know none of you defined it as a picture of a dog. I would imagine you defined it as a dog. So Paige, what's your definition?
I said it's a living thing called a dog.
Okay. Would that be a good definition?
No.
No? Okay. Lily, what do you got? I can't hear you loud and proud.
An animal descendant from wolves with various breeds.
What was the last part?
With various breeds.
Very extreme?
No, various breeds.
Various breeds. Descended from wolves with various breeds. Is that a good definition?
No.
So let's break this apart because we're in the process of learning. Why wasn't Paige's definition good? Paige, why wasn't your definition good?
It wasn't specific.
Very good. Okay. It wasn't specific. It didn't adequately describe the thing that we're trying to define. What about Lily's? Yes or no? Yeah? Why? What makes her definition good?
It's more descriptive.
Okay, good, excellent. It adequately describes the thing we're talking about. What else? Are there any animals that would fit into, any other animals that would fit into her definition? No, right? There's no other, as far as I know, there's not anything else that's descended from wolves. Okay. David, you're shaking your head like you agree, or there is something else that descended? You agree. Okay. So what makes a good definition? Number one, it's got to adequately describe the thing we're talking about. And number two, it has to eliminate things that it isn't. Okay, so for instance, if you just said, well, that's a furry animal. Okay. Number one, it doesn't adequately describe it. And number two, there's a lot of other things that satisfy that condition. A cat, a hamster, a weasel, a bunch of other things. So then, we go back to Lily. Did her definition take into account the differences between these two things? So Lily, you just defined a dog, right? So if we go back to this screen, could you have been more specific with your definition? Yes? No?
Yeah.
Yeah, what kind of dog is that, do you know? I can't hear you.
Labrador.
I don't know if that's a Labrador or a Golden Retriever. It's one of those. So we'll go with a Labrador. I think it's a Golden Retriever though, yes? I don't know dogs very well. Okay, so we'll go with the Golden Retriever. Your definition did not take into account that it's Golden Retriever, right? Okay. So when we get to this, when we get to this next slide then, we would need to refine your definition to exclude, does anybody know what kind of dog that is on the right?
Chihuahua.
It is a Chihuahua, right. So the question is, what are we trying to define? Are we trying to define just a dog, or are we trying to define a Golden Retriever? Yeah, I mean, it's an open-ended question because I didn't specify. I just showed you a picture of a dog and said define it, okay? Are you defining dog? And that's one of the things we're gonna need to talk about is, what are we trying to define? So her definition doesn't differentiate between the Golden Retriever or the Chihuahua, it just defined a dog. And if we wanted to define a Golden Retriever, then we've got to get more specific. In this class, you're going to end up writing almost every definition that we work with. And my job is going to be to guide you so that you don't give garbage definitions, because that'll screw things up. The hard part about it for me is that I teach 3 classes of this, and not every definition is going to be the same. So I'm going to have to try to remember how we define different things. However, there are 3 terms that we're going to use as building blocks for geometry that don't get definitions, because they're very difficult to define. What I mean by that, and we'll just start with this one, what is a point? Now, I'm not going to have an official definition for you for what a point is. What we're going to do is we're going to describe everything about a point. So tell me, what's a point? You've done geometry before, you've done algebra. Aaron?
A place on the line.
A place? A location. So what is it a place or a location?
Location.
Location, and it has to be on a line?
Yes.
Okay. Okay. Casey, did you do me a favor? Go up to the board. Go ahead. I'm going to give you some directions. Grab one of the pens off the front. Click on the right side of the board over there somewhere.
Where?
Just anywhere, and then just tap that space. Whoops. Let's go back. Huh. Tap in the center of the screen. See what happens. That's not working. Tap. Oh, that's what I needed. Okay, so the third one. No. There you go. Third one down. Click on that. Then see where it says pen. Click on pen. Excellent. Now, could you draw a point on that screen, please? Well done. Let's give it up for Casey, everybody. That's a good point right there.
Is that it?
Then stick that back on the front of the board. See where it's got the little note to the left. More. There you go. Excellent. Well done. Aaron, does that fit your definition?
No,
Why not?
because it's not on the line.
Is that what you thought you were talking about, though? Would that, do you feel that Casey did an adequate job of drawing a point? Yeah. Okay, so do you want to revise your definition? Or, I don't want to use the word definition, description of what a point is.
Location, like where?
Location anywhere. How do we feel about that? This is the audience participation part of the program. How do we feel about that?
Good.
Thank you. Of course it's good for you. You said it. Casey, why did you put the point there?
You told me to do it anywhere.
Okay. And you followed through with anywhere on the board. Well done. Okay. So, getting back to that, Aaron, you're describing it as a location. I don't dislike that. There. Okay. Look at that. Point is a location. Now here's the weird part. It has no shape nor size. Well, how is that possible? Casey, does your point have size? Yeah, it does. We could get a really small ruler and measure the size of that point. So how can something exist if it doesn't have any shape or any size? And the answer is it can't. So now we get into some theory here. I have a cup full of points. How many are in the cup? How many? Infinite. Right. Everybody good?
Yes.
Okay. I have a room full of points. How many points are in the room? By the way, I'm in the room with my cup also. So I've got a cup full of points in a room full of points. Jack, how many points are in the room? Infinite. So which is more, the number of points in the cup or the number of points in the room? Neither.
If there's bigger infinites than others, right?
I don't know, that's what I'm asking. So you're saying the amount of points I have in this cup is the same as the number of points that fill this 20 by 20 room?
Yes.
You don't know how big the.
Hold on, I'll come back to you in a second. Is anybody, are we okay with this?
Yes.
Yes? Oh. So I have the same number of points in this cup as are filling this room.
But you don't know how big they are.
How big? Yes, we do. How big are they?
No, they aren't size.
They don't have any size.
Hold on.
It says no shape or size. So we're going with the same. Interesting. Okay. So infinity is infinity. Are you okay with that, Ben?
I'm not.
You're not? Tell me what.
Because I think some infinities are bigger than others.
So like infinity and beyond, Buzz Lightyear.
Sure.
Okay, so Buzz was onto something.
Yeah.
You really think Buzz was onto something?
I do.
What about the infinity plus one? You're stupid. No, you're stupid. No, you're stupid. No, you're stupider. No, you're stupid. You're stupid infinity. Oh yeah, you're stupid infinity plus one. So you would win that argument?
Yeah.
What if I said infinity times 3? What if I said infinity times infinity? What's that? Oh, what if we did infinity raised to the infinity power?
Yeah, it's a lot.
So when do we hit the limit of infinity?
You can't.
You can't. But there are different infinities?
Yes.
No. So this is a problem because the human mind doesn't really, you think you know what infinity means. You have no idea what infinity means. And I hate to admit it, but Jack was right. Infinity is infinity. Okay? It's a concept, it's not a numerical value. Obviously, if you start counting, you're not going to count to infinity, ever. Okay, and you can talk about, we'll talk about very large infinity, okay, the number of points in this room. We'll talk about small infinity. What does small infinity look like? Well, you go out today and you mow half of your grass. And then you go out tomorrow and you mow half of the half. And then you mow half of the half, and then half of the half, et cetera, et cetera, et cetera. Eventually you would get closer and closer to 0, but you will never reach it. And this is going to bother people. So we can't really draw a point. It has no size, it has no shape. And if it has no size or no shape, how do we draw it? Well, we're going to do exactly what Casey did. We're going to use dots to represent points. Just like that wasn't really a dog, that was a picture of a dog. See what I'm doing here? That's not really a point. That's a representation of a point, which we'll call a dot. And we're going to use a capital letter to represent it, so it goes something like that. Now, my dot is considerably bigger than Casey's, but you get the idea. You will never be able to draw a point. You will draw dots to represent points. That concept carries through with a lot of things that we talk about in this class. Okay, you're not really going to draw a cylinder later on. You're going to draw something that represents a cylinder. Okay, we good? That's number one. Now, it's easier to understand going forward if you continue to think of a point as a dot of having size. But from a theoretical standpoint in geometry, they have no size. But again, if you want to wrap your head around this infinity thing, just think of it as a point. So I take a bunch of points and I put them together and I end up with a line. Again, we're not going to define it, but we can describe it. What's a line? Go. Ooh. Can you go back to the board? Can you draw one just so I'm sure we're talking about the same thing?
Oh, yeah.
Huh. Interesting. All right, you can put it back. Have a seat. Is that a line? So if we zoom in on that line, Casey, okay. If we just keep getting closer and closer, what's that thing made of? Just a bunch of points, right? And what's special about just that bunch of points? How so?
I don't know, just like so close together that there's nothing in between.
But what makes them a line and why not just a scattering of points?
Because they're connected.
Okay. But okay, so let's get even simpler here. Let's think of points as golf balls. And I've got 100 golf balls. How do I make a line out of those 100 golf balls?
You put them next to each other.
Okay, we're almost there. But I could just have them in a box and they'd be next to each other.
I don't know.
You understand what I'm getting at here? How do I describe this versus just a smattering of points laying everywhere or dots laying everywhere? Say again? Ooh. Okay, give me a little bit more. What do you mean straight?
Like, not no curves.
So how would you have any little brothers and sisters? Well, let's imagine you do. Let's imagine you have a 4-year-old brother, and you give him a box of 100 golf balls, and you say, hey, make a line out of these. And they look at you like you're speaking Italian. See what I did there? It's Italian week. How would you describe it to your 4-year-old brother how to make a line out of all those golf balls?
Like, keep them straight.
Keep them straight. Does that work for all of you? Yeah. Worked for me. Think a 4-year-old would get grasp that? Right? So they're not going to be dropping them all over the place. They're going to keep lining them up. And I didn't want to use the word line them up, but you're putting them next to each other so it forms something straight. Okay, good. Let's go back to Casey's picture. Is that a line? No. Why is that not a line?
Because like lines can keep going.
Oh, not only they can keep going, they do keep going. Casey, back to you. Can you fix your picture? You do? Go. It's okay, take your time. Nice, let's give it up for Ben. Left, left, left. There you go, well done. Okay, explain, Ben.
So when you like your eyes on a line, it shows that it's like into the other.
Is that a line, Casey?
Yeah.
No. It's not a line. What is it? No? Oh,
Sorry, never mind.
what, you chicken out?
Yeah.
Was that a dog I showed you before?
No.
Picture of a dog. Is that a line? No. What is it? Drawing of a line or a representation of a line. Good. Now this seems like I'm being a jerk about this, but this becomes a standard for our practice in geometry. Things representing other things. Okay. So, Casey, I don't know, I blanked on your name for a second. If I asked you to go to the board and actually draw a line, could you do it?
No.
Why?
I don't know, so I can't draw a bunch of points.
Number one, the points have no size, you can't do that. And number two,
I have no points to take.
good. And number three, how long would it be?
Oh,
Infinitely long, right? That would take you a while to draw. So again, we represent a line by putting arrowheads on it, which means it goes on forever and ever. Okay. If you take any 2 points, okay, so if I had Casey go back to the board and change the color and put 2 points on the screen or 2 dots on the screen anywhere, there would only be one line that passes through them. And then how are we going to name a line? Well, let me show you a picture of one. I got one right there, okay? So here's my representation of a line, and we're going to name it a couple different ways. Casey, another question for you. How many points did you say were on this line?
2.
No.
Oh, infinite.
Infinite, correct. So there's an infinite number of points on that line, but I picked 2 of them and made them feel special. I gave them names. I picked that point over there and I called it B, and I picked that other point over there and I called it C. There were an infinite number to choose from. I picked 2 of them. So one way to name a line is to pick 2 special points on the line and put in a line symbol over it, which simply means the line that passes through B and C. Could I also do this? Is that the same line? Yeah, just going in a different direction. That's the most common way we're going to name lines. However, we can also sometimes represent it with a lowercase letter. So that would just be the line M. Okay. This will be our most common approach, though. Okay, so let's review before we go on to term number 3. We started with a point. Oh, I forgot to ask you. How many dimensions do you live in? No. This is the 3-dimensional world, correct. How many dimensions does that line have?
2.
No.
3.
1. Length. That's it. Now you're thinking 2 because it's got a thickness. Remember, it has no thickness. How many dimensions does a point have? 0. Very good. So we started with a 0-dimensional point that has no size, and then we lined a bunch of them up, for lack of a better term, and we ended up creating a line. So we stretched it in one direction or in one dimension. Now we're going to stretch it in the other direction, adding more points to it and more points to it. So if I take that line and I stretch it this way, we're going to get our third term, which is called a plane. So think of a plane as being an infinitely large piece of paper. Goes on forever and ever. How many dimensions? 2, correct. Most of the work that we do in geometry up until the spring will involve 2 dimensions. Hence the reason it's called 2-dimensional geometry. We won't get to 3 dimensions until probably February or March. How do we represent a plane? Well, you're working on a plane. If you think about a notability document, is pretty much a good representation of a plane because you can go in all directions on a notability document and it just keeps getting bigger and bigger and bigger. The slideshow that you're writing on, you can think of that as a plane. The face of your iPad can be considered a plane. The screens are planes. And we'll use a script letter to represent that. Fancy capital letter. And you recall when we were talking about lines, I said any 2 points, you can have a line go through any 2 points. If we expand that in for a plane, any 3 points will go through a plane. Now, how do you remember that? It's real simple. You ever sat in a chair where one leg is shorter than the other and the chair rocks? Okay, that's because the chair has 4 legs on it. Why do cameramen use a tripod? Because tripods will always balance. It doesn't matter if one leg is shorter than the other. It will always sit flat because those 3 points, the end of the tripod, determine the plane that that tripod sits on. Or a 3-legged stool will always balance. Okay, how we doing? We're good? All right. Now, we've got your official first 2 definitions. Because we're not going to really count the dog. Okay. First 2 geometric definitions, it should say. What does the word collinear mean? Yeah.
Together line.
Together line, okay. What are you, a caveman? Could you phrase that a little
Wait,
bit more
sorry, no, no.
eloquently? What is it?
Wait, was that right?
Well, kind of, but it
Like
sounds silly.
lines
Together
together.
line.
Lines-
Teacher, me. Geometry take now. Class go.
Like lines together.
Not lines. Points. That are on
The same line?
the same line. Very good. Okay, co is the prefix meaning together. Linear means line. Together on the same line.
This makes sense.
Eva, what would non-collinear mean?
2 or more points that are not on the same line.
Perfect. Okay, even 2 more definitions for you. You ready?
Yeah.
Good. What is coplanar?
Wait.
How long am I waiting?
Points on the same plane.
Well done. You're almost done. 1 more for you. What's the next word going to be?
Non-coplanar.
Which would mean?
Points that are not on the same plane.
Well done. Gesundheit. Gesundheit. The 3rd for a hat trick. You know what a hat trick is? 3 goals in the same game. 3 sneezes right away when you get the trick. Anybody play hockey? Anybody know what they throw on the ice after a hat trick in Detroit? Octopus, correct. Yeah. So some number that comes to every game of an octopus. All right, everybody caught up? We're good? Excellent. Okay, so let's draw some pictures. This will be fun. In your notes, sketch the following. I'll just put them both up there and then you can figure it out. Number 2 is considerably easier than number 1. I'll give you a couple of minutes to draw them, and then we'll take a look at some answers. Make sure it's labeled correctly when you draw it.
It's kind of already sitting on it, isn't it?
I think the R should be in low key though.
Interesting. All right. Whoa. Nice. So the big question with number one is, well, how do I draw a plane? You could cheat and say, well, the thing that I'm working on is a plane, so I'm just going to put a line XY on there. However, we want to doctor it up a little bit. So I have this. The yellow represents the plane, and then I have that line going through there. Why is, okay, use English reading. Why is that line partially dashed?
That's where it intersects the plane.
Kind of.
That's where it goes on the other side.
Very good. Where it intersects the plane is the point M. Okay, that's commonly called the foot, by the way. That's the point of intersection between a line and a plane. The dash part is behind it. So what I'm doing is I'm trying to represent 3 dimensions with a 2-dimensional picture. Not very easy to do, and thankfully we're not going to do a lot of it this semester. That's all second semester stuff. But if you have to, you got that. Okay, now notice I labeled the plane in the lower corner with that fancy script R. I've got 2 points on the line, X and Y, labeled with capital letters. And because the point of intersection between the line and the plane is a point, it's labeled with a capital letter. Number 2, I saw most people got number 2, no problem. 2 lines intersecting, line M and line N. They should have arrowheads on it because we talked about that. Arrowhead means it goes on forever. And the point of intersection is Q. Any questions there? Hot diggity. As far as those 2 practices go, number 2 is much more important than number 1. We'll get to number 1, 3-dimensional stuff later on. Okay, so what's a line segment? Oh, go draw one. You are 100% correct. Now we'll see if you can draw it.
Like, say like this would be like,
But that's a line.
yeah, I know, like this would be like a section,
You
like
can't, oh, what are you doing? Oh,
Like this
don't
would
put your
be-
hand on the screen.
this would be like a section, like a segment X, and that would be segment Y, maybe. I'm not sure how to draw.
All right, go over where the pen is.
Okay.
Third one down. Click on that. Okay, switch to eraser.
Okay.
Erase that mess. Okay. Oh, yeah, get it? Okay. Now, without all the other, switch back to pen. So click on that. And you can change the color if you'd like, if you're feeling saucy. You can stay with red.
Yeah.
Okay, so forget all the hoopla. Just draw me a line segment.
I don't know how to
You
draw.
can't do it?
No,
Okay?
I don't.
Well, bring that with you. Bring the pen with you.
Okay.
Give it to Casey. Well, you want to go?
I want to try.
All right, go.
No, I was just.
Casey's going to probably give you the opportunity.
Yeah.
Is that it?
Well, I don't know. Ben, is that it? Is that part of a line?
Yeah.
Yeah. Okay, you can sit down. And we're gonna pretend that it's straight. Yeah, they're not, has it, we're bending it. But if that were straight, you're saying that's a line segment?
Yes, I know.
Good, so what is a line segment, Ben?
Section of line.
Section of a line. Love it. Oh, but wait a second. By the way, for the rest of you, how do we feel about the definition, a section of a line?
Good.
Good?
Pretty good.
Solid?
Comprehensive.
Excellent. Let's not go with it. Why? Well, what if I do this, Ben? Is that still a section of a line? That.
Yeah.
But you didn't answer my question. Is that still a section of a line?
No.
Say yes, it is.
Yeah.
It's a section of a line.
Yeah.
But that's not what you intended, right? Casey, that's not what you intended, right? I shouldn't have arrowheads on this. So how do I revise my definition? Whoa, whoa. Sorry, Case. Wow, that's a train wreck. How do I revise, or how does Ben revise his definition to take into account that versus with an arrowhead on it?
It's a line that connects two, or a segment of a line that connects 2 points.
That's not horrible. In fact, I kind of like it. Could you say it again?
It's a section of a line that connects 2 points.
Good. How long is that?
Infinite. Or, well, the distance between the 2 points.
So you could tell me how long that line segment is. Right. All you need is a ruler, right? Okay. Could you tell me how long a line is? No, it goes on forever and ever. Infinity is not a number, so the answer is 1. Good. Good. So a line segment is, say it again, a section of a line connecting 2 points. Okay. Those points that he's talking about are called endpoints. Okay, I labeled mine A and B, Casey labeled his X and Y. It doesn't matter. Now notice the symbol above the letters changed. It's a line segment symbol. If I'm talking about a line, you put a line above it. If I'm talking about a line segment or just a segment, you put a line segment above it. How many points on that line segment? Good, infinite. But we made 2 of them special, gave them names, and put them in the endpoints. I've actually, well, we've done that already. Thanks, Casey. Good job. When you draw your line segment XY in your notes, please then put a point Q on that line segment so that it's between X and Y. All right, I'm going to clean up Casey's picture a little bit. Well, actually, I'm going to clean up the mess that I made of Casey's picture. It's all my fault. Okay. So put Q between X and Y. We good? Good. Faye, go to the board, please. Grab one of those pens and put Q on that line segment, please. Well done. You can sit down. Great job. How'd she do?
Good.
Yeah? Q is between X and Y. Oh. Annie, go to the board, put Q on there, please. Is that also between? Was that a yeah or a no? Yes. How many different locations could you put Q? An infinite, right. Okay, now here's the hard part. What does it mean for a point to be between two other points? Alan?
Means that like the line has that
Line?
the segment is like cross that point at some point.
Okay, I know what you're saying, but your terminology is a little sloppy. Instead of the line crossing the point, can't we just put the point on the line segment? Yeah, okay. So between this, we're gonna simply define as being on the line segment. Q is between X and Y if Q is on the line segment X, Y. How many of you put Q smack dab in the middle? Is it still between?
Yeah.
Yeah. Got that, got that. There's mine, AB, great, fantastic. Let's move on. We have two different notations, well, we have a lot of different notations. We talked about a point being a capital letter, we talked about a line, we talked about a line segment. We have two different notations now. On the left-hand side, we're talking about a line segment AB. The segment connecting points A and B. A and B are the endpoints. You draw a segment between the two, you're good to go. Notice that the one on the right has no symbol above it. It's not a line, it's not a line segment, it's 2 points. What that notation represents is the distance between those 2 points. So when I ask you to find AB, you need to look carefully at the notation. Am I asking you to just draw an arrow where segment AB is or where line AB is, or am I asking you to find the distance between A and B? Good? Everybody good to go here? Okay, as I mentioned, we're going to incorporate some algebra into this. So here's a scenario. I'll let you read it because I know you can all read. Give me a second to read it, and then I'll work this problem with you or for you, and then you'll try one on your own. So before we even get started, just for giggles, try to draw or sketch a picture of what's going on here. Go ahead, draw a picture of what's going on here. Okay, good start. Now keep going. Okay, so let's start with the picture first. What should that picture be of? What are we talking about here? Good. How did you label the line? Okay. How did you label the line segment is what I tried to say. In other words, what are the endpoints of the line segment? A and C, good. And then what'd you do?
I drew B in the middle.
Does it have to be in the middle?
No.
No, but it's gotta be on the line segment, right?
Yeah.
Okay, then what did you do?
I put 14 in between names of B and C.
Good.
I put 3x in between B and A.
Uh-huh.
And then I put 5x minus 4 off to the side between A and C.
Well done. So, maybe something like this. Mine's a little fancier, but, yeah. B does not have to be in the middle. It's just gotta be on the line segment. And then I labeled it with the appropriate values like Casey talked about. This guy is 3x, this guy is 14, and the whole length is 5x minus 4. Case, any chance you put together an equation for that bad boy?
No.
Anybody? What equation do you get from this picture? Lena, what do you got?
3x plus 14 equals 5x minus 4.
Amazing. Well done. Okay, so again, let's break this into simple terms. If I know that that entire segment is 10 feet long, then the two little pieces have to add up to be 10 foot. 7 and 3, 5 and 5, 4 and 6, whatever. So she recognized that I got this little guy AB, and if I add that little guy AB to the big guy BC, I'm going to get the huge length of 5x minus 4. Any chance you solve that?
Yeah.
What'd you get?
AP equals 28.
So you did. What did you get for x?
Oh, 9.
9. Can somebody confirm?
Yes.
Good. And then you got a total length of?
28.
Well done. That's right. Let's see. That's what. Oh, I got 27.
Oh, wait. Whoops.
3 times 9, 27, not 28. All right, simple question. Let's suppose AC is 10 feet. Let's suppose AB is 2 feet. How long is BC? 8. Is that a difficult question? No. Let's suppose AB is 4 and BC is 7. How long is AC? 11. Beautiful. Again, keep it simple, stupid. It doesn't matter if it's algebra or if it's just simple numbers. Those two little guys have to add up to be the big guy. Questions? Okay. Try that one on your own. Question? Your theories. Guess what?
So I wrote that. So could I do just like 7x plus 45?
You can do a lot of things. What do you want to try?
Could I try 7x plus 45 equals 5x?
Well, I would ask you, does that make sense?
No.
Okay.
Could I wait? So would I put
Bang.
all the numbers together and then subtract on our side equal
I
something?
don't know.
Okay.
One of the things that's going to happen a lot is in a problem like this, I'm actually asking you for two things. What am I asking you for? And ST. Make sure you answer the question / questions being asked.
The distance from us to a negative 45, this has a downward side. It's not. But how'd you get on it? Oh.
Jenna, what'd you get for X?
4.
Okay. Anybody else?
For X?
X?
Yeah,
4. What'd you get for ST? Salamander turtle.
28.
28. Okay. I don't know if I have the work here. No, I don't. You want to go play with the board and put your work up there for me? Don't lay your hand on the board, just use the pen. Good start.
Wait, oh no.
Whoa, whoa. I don't know what you're doing there, but stop it. Well done, let's give it up. To the left, to the left, to the left, to the left, down, down, there you go. Okay. So while you were working, Lena asked me a great question. She said, well, wait, if the whole thing is 45, couldn't I take, if I take 45 minus 7x, well, I'll ask you, if I take 45 minus 7x, what will we get? 5x minus 3. Could you do it that way? Yeah, 100%. Most people, however, like adding better than subtracting, and you gotta be careful subtracting, because you need parentheses also. But yes, 100% you could solve it that way. More notation. Now, one of the things you need to realize is mathematicians / geometers, we're lazy. And we create a symbol or an abbreviation for just about everything. So these two segments are what's called congruent. What does that mean? Nope. Good guess though. Sebastian?
Equivalent?
Be more specific.
The same?
Be more specific. They're the same?
Same distance?
Oh, there you go. Okay. All right. So now we get into more nitpickiness. I could say the following. Okay. I could say that CD is equal to AB. What does that mean? That means that the length of CD is the same as the length of AB. We're comparing numbers there. And again, this is where we get overly picky. But that's what geometry is all about. Versus what you initially said, Sebastian, is you said they're the same. Right? Great. If I was going to do that, I would write this. Now, you notice there's a new symbol in there. That's an equal sign with a tilde over it. That means congruent. And what congruency means, let's go do a couple clicking here. Congruent segments have the same measure, so that's what the top thing says. You know, 2.5 feet is equal to 2.5 feet. What congruency actually means, though, is same size, same shape. They're exactly the same. We will flip back and forth between those two. Most of the time we'll use the term congruent, and that's our new symbol there, an equal sign with a tilde over it. And it means same shape, same size. You could have two things that are the same shape, but not the same size. Let's say, for instance, you had a Hot Wheel car of a 57 Chevy. Okay. That looks just like a 57 Chevy, but obviously it's not the same size. For congruency, it's got to be both. Same shape, same size. And then the other thing is we're going to be doing a lot of pictures, and we want to easily be able to represent things that are congruent or equal in a picture. So you'll notice those two little dash marks on the segments. That's an easy way of showing that segments are congruent in a picture. Putting the same mark on them, they're called tick marks, and you can do whatever you want. If you want to use 2 tick marks, that's great. If you want to put a triangle over this and a triangle over this, it doesn't matter, smiley face here and a smiley face here. In simplistic terms, what it means is if they have the same logo on them, they are congruent. So we're going to deal with these big pictures, and you want to be able to easily denote that segment XY is congruent to segment JK. Okay? And we can do that using tick marks. Most commonly, we'll use 1 tick mark or 2 tick marks, etc., etc., etc. Okay. Any questions? All right, so we're done. That was a lot longer than we will normally have these kind of lessons, but there was a lot of information to cover today. The other thing that you may or may not have noticed is that I started recording this lesson. You be quiet. When I started recording the message.